Andromeda's father.
Welcome to Stargazers. I'm James Albury, director of the Kika Silva Pla Planetarium in Gainesville, Florida.
And I'm Dean Regas, astronomer for the Cincinnati Observatory. We're here to help you find your way around the night sky. This week, we're going to talk about a constellation that's part of an ancient celestial story.
And more excitingly, one of its stars helped astronomers determine the size and shape of our own galaxy and the distances to nearby galaxies. Wondering what we're talking about? Let's show you. Okay, we have our skies set up for an hour after sunset any night this week, facing north. Off to the northeast, you'll see the familiar W-shaped pattern of Cassiopeia, the Queen. The stars that mark the constellation, starting from the top down, are Kaf, Shedar, Tzit, Rukba, and Segan.
If you draw a straight line from Shedar to Kaf and keep on going, you'll run smack dab into a constellation that looks like an upside-down house. This is Cepheus the King. Cepheus was the husband of Cassiopeia and father of Andromeda.
The brightest star in Cepheus is Alderaan, and it's 49 light-years away from us. Its Bayer designation is Alpha Cephei, so named by German astronomer Johann Bayer, who named the stars the Greek letter based on their brightness, and the Latinized name of the constellation. Being the brightest star in Cepheus, it was named Alpha Cephei.
Alderaan lies very close to a region of the northern sky called the precession circle. Over a period of 26,000 years, Earth's rotational axis passes through several constellations, tracing out a giant circle in the sky. Right now, our rotational axis is pointed toward Polaris, our current North Star. However, in 7500 AD, Alderaan will be our North Star.
Traveling counterclockwise from Alderaan, we have Alpherk, also known as Beta Cephei. Alpherk is a multiple star system approximately 690 light-years from Earth. Alpherk will be our North Star between 5200 AD and 7500 AD.
The next star in Cepheus is Erai, also known as Gamma Cephei. Erai marks the point of the roof of the house-shaped constellation and is a binary star system approximately 45 light-years away. Erai will become our North Star in less than 1,000 years, and it will retain the title of North Star for over 2,000 more. In 5200 AD, it will have to relinquish the title to both Alpherk and the next star in Cepheus, Iota Cephei.
In 6000 AD, the Earth's axis will point smack dab in the middle between Alpherk and Iota Cephei, and for almost 2,000 years, they will seem to perform a nightly waltz around our north celestial pole.
Iota Cephei is a single star approximately 206 light-years away from us. It's over twice the mass and over 57 times as bright as our own sun.
The fifth star in Cepheus is Zeta Cephei, an orange supergiant star over 830 light-years away and over 8 times the mass of our sun. The mass value is important because it's very likely, from what we know about the processes that happen within a star, that Zeta Cephei has enough mass to ultimately go supernova, producing a very dense white dwarf as a result.
The last star we'll talk about is one of my favorites. It's Delta Cephei, and it's just up and to the right of Zeta. This star is special because it's the prototype for a class of stars that astronomers called Cepheid variables, and it's because of this star that we know the distances to nearby galaxies.
In 1784, a young English astronomer named John Goodricke began observing Delta Cephei and noticed that it varied in brightness at regular intervals. This discovery laid the groundwork for measuring distances in the universe.
In 1908, astronomer Henrietta Leavitt was studying thousands of variable stars in the Magellanic Clouds, and she noticed that many stars were found to have this same relationship.
Once the pulsation period for a particular Cepheid variable is determined, astronomers can get an accurate measurement of the star's distance by comparing the star's known luminosity to its observed brightness.
This relationship was so strong that it allowed astronomers to establish the size and shape of our galaxy.
Isn't astronomy wonderful? And it's all waiting for you when you keep looking up.